You're listening to The Solution, a podcast by Growers Mineral. I'm your host, Russell Bobel. In this ongoing series, we will be taking a look at the book More Food from Soil Science, a book written in 1965 by one of Growers' co-founders, Dr. V.A. Tietjens.
Chapter 9. Drought and rainfall control yields, but there is much man can do to offset their hazards. Water is all important in the growth of high yields. In desert areas, irrigation may control the growth of crops. Without rainfall, we may grow fair crops. But where we depend on rainfall, we can be hurt by too little rain and by too much rain. In itself, rainfall is not the determining factor. What we do with it when it falls on our land is the important consideration. This determines how much damage insufficient or excessive rainfall does. In most cases, our utter dependence on weekly or biweekly rainfall is due to poor farm management. Distribution of rainfall affects most of our practices. A widespread lack of rainfall can do us much damage if we let any rainfall run off. With proper management, every drop of rainfall should be absorbed by the soil with little surface erosion and stored in the lower levels where the roots can reach it when they need it. This could make the difference between no crop and a good crop. I have seen it make the difference between 25 and 125 bushels of corn. The problem of getting the water to soak in is discussed in the chapters on subsoiling and liming. Tomatoes ordinarily grow best on a moderately dry soil. I have seen a 25-ton yield produced on a soil that had one rain of 1 inch 2 weeks after the plants were set and no more rain until the crop had been harvested. Too much rain may or may not damage a crop. If we have excessive rain and the water runs off or infiltrates the subsoil, it usually does little damage. When stored in the subsoil for future use, it is ideal. If the water soaks into the plowed layer and stays there because of a plow sole, roots can be smothered, especially if it happens during periods of hot weather about 70 degrees or above. An increase in temperature throughout the growing range for a given crop speeds up respiration, which means more rapid exchange of carbon dioxide and oxygen. Any interference with the removal of carbon dioxide from the root surface may cause degradation and death of the cells, which are sloughed off by the plant. If the temperature stays cool, very little damage may result, because respiration is slowed down. At 70 degrees or higher temperatures, the plant becomes very active, respiration is rapid, and the roots must get rid of carbon dioxide before it becomes toxic. If it stays around the roots, they die from lack of oxygen. The roots must absorb oxygen from the air in the soil, and if the soil is full of water, there is too little change of air. The only cure for this is to have soil open enough so the water can leach down to the natural water table. Most thinking on this subject is directed at tile drainage, but that thinking is faulty. Tile drains are only desirable for the purpose of lowering the water table. For this purpose, tile has a very limited use, since there are very few cases where it is desirable to lower the water table. If we tile all our soils, all we do is allow the rainfall to trickle or seep through the soil, collect calcium and fertilizer nutrients on the way down, and carry them to the tile so they can be carried off the land to the rivers and the ocean. A soil with natural drainage should not be tiled. If it stays wet, the physical condition must be changed by applying limestone. The only advantages of carrying water away from the land is to feed the fish. I wonder how farmers can afford to do this. They buy fertilizer to put on a land and then tile it so the soluble parts of the fertilizer which our crops need runs to the rivers and eventually to salt waters. Rainfall causes floods if it is excessive. The only measures we have taken to control floods are to build dams to hold the water in large reservoirs to slow down its race to the ocean. We complain that farmers have cut down the forest, so the waters flow off too freely. Few seem to realize that our river valleys were formed by floods long before man was on this earth. Heavy rainfall has always caused floods. Damming rivers to hold back water is a worthwhile procedure if we use the water for irrigation when we need it. Floods cost farmers money, not so much because of physical damage, but because so much good soil and plant food is carried away. If we would subsoil and apply sufficient limestone to our cultivated lands so the soil could absorb the water as fast as it fell, we would not only control our floods or at least greatly reduce water runoff, but we would more than double our yields. And there is also a possibility that we would reduce the money spent for fertilizer. Excessive rainfall, properly handled, will do minimum damage and can do much good if stored in the soil for future use. We must know soils to know procedures. The big problem is to get the water away from the roots in the plowed area and to encourage roots to seek water in the subsoil. In this way, the surface soil is free of excess water, and it's possible for the roots to get all the air they need. This is best done by providing good aeration with a subsoiler and adequate applications of limestone. This results in good surface drainage. And when I say good drainage, I mean free seepage from the surface to depths of 2 to 3 feet in the subsoil. A farmer in one of the eastern states came to Mr. Charles Nisley and myself about several ponds on his farm. He was renting the land and had the option to buy the farm at a low price, which he would do if we could show him how to drain it. One 25-acre field on which he usually grew potatoes had a 2-acre pond in one corner. It has been used for a skating rink every winter for 15 to 20 years. Every time it rained, the water ran off the field to the pond, keeping it filled. There was no outlet, nor could the water soak into the subsoil, so the pond always had the water standing in it. The first thing we did was to run a subsoiler 25 inches deep at 3-foot intervals around 2 sides of the farm side of the pond. The other 2 sides had a fence row and a state highway for boundaries. Following the subsoiling, the pond dried up because rainwater could not run into it. Then we limed the field with 4 tons of limestone and subsoiled it lengthwise and crosswise to speed up the movement of the limestone into the subsoil. All the fields had the same condition, temporary ponds that formed in each. We gave them all the same treatment with the same results. A permanent pasture, which was very rough, was also very swampy. This, too, was given the lime subsoiling treatment. It dried up the swamp and permitted the farmer to establish good pasture for night use. He grew good corn and potato crops every year after that because he stored his rainfall in the subsoil where it could be used by his crops in case of drought. Almost every year in some area of Ohio as well as other states, we have rather heavy rainfall in May and June. In those areas, particularly in unlimed soils, corn comes up and, when it is a foot high, turns yellow, in spite of the fact that the farmer followed state recommendations. Some of these farmers side-dressed with nitrogen, but it did no good because the cause was not a shortage of nitrogen. The real problem was a deficiency of calcium, which prevented good physical structure and prevented water from moving away from the roots to lower depths. The stagnant water soon lost its oxygen and the corn roots smothered. If the ground was dry enough, you could cultivate, but when it dried, the corn would turn green anyway, if root growth was still possible, because when the water left, air immediately penetrated and supplied the necessary oxygen. A number of years ago, in one eastern state, we had heavy rains when potatoes were 8 inches high. The foliage in the fields turned yellow and, thinking that the nitrogen had washed out of the soil, the fertilizer people sold a lot of nitrogen for side dressing. I was working with Mr. Fred Bateman on fertilizer experiments. He had a 50-acre potato field, which was very sandy and slightly rolling. His potatoes turned yellow in the lower part of the field. We walked between the rows and noticed that every 5th or 6th plant was green. Those in between were yellow. We got a spade and dug up 10 feet of one row. The green plants had their roots well into the subsoil, 16 inches deep. Those between had their roots only in plowed soil. When we checked further, we found the green plants lined up across the field in rows 5 feet apart. I suggested it was a carryover effect from fertilizer the previous year. Last year, he told me, the field was in rye with no fertilizer. The year before, it was in corn, but the rows were fertilized the same direction the potatoes were. The year before that, the field was in tomatoes. They were planted in rows crosswise to the potatoes and 5 feet apart. What did you do to the tomatoes? I asked him. He subsoiled under the rows and put a mixture of 1/4 gypsum and 3/4 limestone under the plants. He made a furrow a foot deep, placed the mixture in the bottom, covered it up, and set the plants on top. We had a big crop of tomatoes, he told me. The gypsum had promoted deeper drainage and aeration. Here again, we have a demonstration of the damage that too much rainfall can do if the water can't seep into the subsoil because of a plow sole. In a dry season or one with normal rainfall, you might not see any effect except that the yield might be much better where the plow sole was broken up. It has been my experience that we have fewer problems with heavy rainfall on sandy loam soils with low levels of clay and organic matter than we do on those heavy soils where clay and organic matter are high. Water moves more slowly through the heavy soils, and during hot weather, damage from heavy rain can occur before the water has a chance to seep below the plowed layer. With continuously heavy rainfall, the plowed layer actually becomes swampy, and we have surface swamping on what is considered high fertile soil. We must not underestimate the oxygen problem here. Adequate limestone plays an important part in correcting it. In areas of heavy rainfall, these heavy clay soils are ridged up and crops are planted on the ridges. The first time I saw a field of back furrows on 40-inch centers, I thought the person was out of his head. But when I saw nice green corn in spite of a wet spring, I realized that this was a practice assuring good aeration. When I talked with the farmer and asked why he did it, he said that his father always did it in coastal North Carolina. Since then, my experience over the years has shown that it is an easy way to get good yields on soil that is high in organic matter, high in clay, and where water seepage horizontally and vertically is too slow in hot weather when respiration in the plant is at its maximum. A farmer called me and wondered why corn on one side of his field was not growing satisfactorily. When I saw the field, I realized what had happened. He did too, as soon as I started to tell him. He had a field of sugar beets alongside the corn. They were growing very well. He had prepared the sugar beet ground a month before the corn ground was prepared. He overlapped on the cornfield, and several weeks later, when he prepared his corn ground, this strip was working a second time. The heavy rains came when the corn was a foot high. Most of the corn recovered and made a good growth, but the strip that was overworked never entirely recovered. The year 1960 was a wet season in parts of Ohio. We have an experimental farm at Olena. It was in an area of silt and clay loam in which most of the rainfall runs off the land. It is low in calcium. It has a fairly high pH. We had a heavy rainfall in May and June. The soils on neighboring farms were worked excessively because every time it rained, it had to be worked again. This happened 3 times on some farms. Corn was planted on these fields and it germinated well, except in areas that were underwater. Since soils on the Olena farm were so variable, we had spotty fields. We plowed and planted on our wet soils and grew over 100 bushels of corn. But with several more rains, the corn on much of neighboring land turned yellow and stayed yellow all season, in spite of the fact that some growers side-dressed with nitrogen fertilizer. The yield naturally was very poor. On our farm, we plowed late and planted corn after June 1st. We did not work much on the ground, had no yellow corn, and had harvested as much as 137 bushels. The rain did us a lot of good because our ground was limed and was not packed from overworking. Where we had a low calcium reading and considerable clay and organic matter, our corn turned yellow because the roots could not get oxygen. We applied oxygen around a few plants in a test plot and grew 100 bushels of corn, instead of the 35 bushels where we did not apply oxygen. We had some yellow corn that was planted earlier on ground that was disc-harrowed once. When the corn was 15 inches tall, we pulled the subsoiler between the planted rows to get some air down to the roots. It was amazing how soon the corn turned green and started to grow. When we harvested the corn, we found that subsoiling had increased our yield from 50 to 103 bushels. In this same area, but where the corn was hurt the most, we selected 6 plants in 6 locations in the area. Plants 3 and 4 were definitely poorer than 1 and 2 and 5 and 6. We bored 2 holes 12 inches deep alongside each plant. The holes around 3 and 4 were filled with pure oxygen gas and sealed over. All the holes were sealed over. From plants 3 and 4, we harvested ears that were 8 inches long and well filled out. The ears on the other plants were poor nubbins 2 to 4 inches long. Too often we think that yellow corn means nitrogen deficiency, that purple corn means phosphorus deficiency, and that marginal burning of the leaves means potash deficiency. Perhaps they do, but a lack of calcium, too much rainfall, or compacted soil may cause all these characteristics to appear. These are deficiency symptoms, but they cannot be corrected merely by supplying the deficient ion. This confuses the issue when we try to correlate soil tests with yields. Because of the variation in rainfall, each farm in each area can have different results and different problems from one year to another. One wishes that a farm could be run with the aid of a slide rule or a chemical test. Such a utopia is a long way off. Perhaps we will have to wait until we can visit other planets to find the answer. So far, our brains have not even assured us of consistently high yields on one given farm in one particular area. Many cultural practices play an important part in our yields. As colloidal clay and organic matter increase in quantity in a soil, our cultural problems become more complex. Farmers have practiced subsoiling for many years, but most experiment stations that have investigated the practice at intervals have concluded that the practice has no value. Conducting such experiments without regard to the water content of the soil is a waste of time. The object in subsoiling the ground is to break up the subsoil, leaving fissures running in all directions. This promotes better movement of air and permits rapid movement of water from the surface to the subsoil, where the water can be stored for future use. It also helps to speed the movement of limestone from the surface to greater depths, which encourages roots to penetrate the lower soil horizons. We have also used the subsoiler to open the soil between rows of corn, where the foliage was 16 inches tall and exhibited a yellow-green color indicating nitrogen deficiency. 3 days after this practice was followed, the corn turned dark green. The practice increased the yield from 47 bushels to 103 bushels. Subsoiling has always given a worthwhile response when the practice was followed during the season when the ground was hard and dry. Many farmers who have silt and clay loam soils plow their ground when it is too wet. If the soil is wet enough to show a glaze after it is plowed, it probably is too wet. Farmers are anxious to plow their ground as early as possible, partly to get the work done. Often, the surface of the soil is dry, but the bottom of the furrow is wet. As heavy equipment moves over the surface, the plow soil becomes puddled and bakes hard as it dries out. Roots won't penetrate this hard subsoil, thus the roots are shallow and are at the mercy of the weather, particularly when it is dry. Farmers often work the fields several times after plowing, and if rain should fall, they have to work the soil again. The soil becomes packed and weed seed germinates in abundance. Then it is necessary, by means of a rotary hoe and cultivators, to control weed growth and loosen the soil so that the roots of the crop have adequate air. Minimum tillage as a practice of plowing and planting is often practiced for spring crops. The ground is not plowed until it is time to plant the crop. The ground remains loose, and because it does not provide sufficient moisture, weed seeds won't germinate until sufficient rain has fallen to pack the soil around the seed. Growers have told me that they have practically eliminated troublesome grasses by following this procedure for 3 years.
Thanks for listening, everyone, to this episode of The Solution. If you'd like to learn more about the Growers Program or anything you heard in this podcast, visit our website at growersmineral.com. Make sure to subscribe so you don't miss another episode. Thanks. We'll see you guys in the next episode.